Hi class. In order to prepare for your exam tomorrow night, I've prepared this video of solutions to the exam 3 review. Um, First kind of question that's going to be on the test, or the first topic, is the related rates problems. And if you remember, this is the type of problem where we want to think about what's changing with respect to time in this problem. We've got a 10-foot ladder that leans against the building. Base of the ladder slides away from the building at a rate of 2 feet per second. All right, so this side down here, I'm going to call x of t. It's changing with respect to time. And then if that's sliding out, then this is also going to be changing with respect to time. All right, so we've got these two sides of the are going to be changing with respect to time. And then we're also given a little bit of information that the ladder slides away from the base at a rate of 2 feet per second. So this is going in this direction at a rate of 2 feet per second. And then the question is, how fast is this point sliding down the wall? Alright, so the next thing I want to look at then is setting up some kind of a relationship between these two functions. We know that this ladder is 10 feet long and it's not changing. And so one thing that's going to relate x and y is this is a right triangle, and in the right triangle Pythagorean theorem is going to hold. So we can say that x of t squared plus y of t squared has got to be equal to 10 squared, or 100. And then, if you recall, the process was take the derivative of everything with respect to t. So using the chain rule here, we're going to get 2x of t times x prime of t plus 2y of t times y prime of t, and then is equal to the derivative of 100, which is just 0. Okay, and then think about what we're looking for. We're looking at how fast is y changing, and mathematically that represents the derivative of y with respect to t. So everything else we ought to be able to plug in. So we get 2 times something plus 2 times something times y prime of t is equal to 0. Okay, so the problem said that the base of the ladder is sliding out at 10 feet, or at 2 feet per second. The rate at which the top of the ladder is falling when the base is 6 feet from the building. All right, so we're wanting to know when this is 6, x prime is how fast this thing is changing. Well, that side is going to be increasing at a rate of 2. And then when this is equal to 6, the ladder is going to be leaning up against the wall here, and we got to think about, well, what's y going to be when this is 6? Right? Well, the Pythagorean theorem has to always hold, so whatever y is here, if we square it and add 6 squared, we should get 100. Right? Which tells me that y squared is going to be equal to 100 minus 36 is 64, so y is 8. Okay, so we get 8 for an answer here. Okay, and then we want to solve for y prime. So we've got, this is 24 plus 16 y prime of t is equal to 0. If we subtract the 24 over, we're going to get 16 times y prime of t is equal to negative 24. And so y prime is going to be negative 24 over 16. Which is the same thing as the 8 goes into both of those, so negative 3 halves. And then I didn't ask you to put units on this one, but the units would be feet per second. Feet per second. So this is going to be dropping at a rate of 1.5 feet per second at that instant. Okay, then the next question is the ladder, the wall, and the ground form a right triangle. Okay, the triangle up here in the picture. Find the rate at which the area of the triangle is changing when the base is 6 feet from the building. Alright, so now let's think about, we've got 3 things that are going on in this equation. Area is equal to 1/2 base times height, but we got to remember that the area is going to be changing with time. Okay, and that's going to be equal to 1/2. The base, which we called x of t, is going to be changing with time, and y is also going to be changing with time. All right, so there's a relationship that gives me, or an equation that gives me a relationship between area and the two sides. So what we're looking for is find the rate at which the area is changing. We're looking for A prime. All right, so to find A prime, I've got to take the derivative of this side and the derivative of this side. All right, the 1/2 is just going to be a constant, so we can kind of worry about it at the end. And then we want to think about taking the derivative of what's left. All right, well, what's left is a product, so applying the product rule, we're going to get x prime of t times y of t plus x of t times y prime of t. Okay, that's the product rule. All right, and then we're looking for A prime of t. That's going to be equal to 1/2, and then we should know all 4 of these pieces. So x prime that was 2 again. And y of t, that was the height of the ladder at that instant, was 8. Plus x of t. X of t was 6 feet away from the base. And then y prime is the number we came up with in part A. That's going to be -3/2. All right, so when we evaluate this, we're going to get 1/2, 2 times 8 is 16. 3 times -3/2 is going to give me -9. All right, so we're going to end up with 7 times 1/2 is 7/2. And then if I ask you for units on this one, we're talking about how fast is the area changing. This would be in square feet per second. Okay? All right, so that kind of question was called related rates problems, and I think if you go back and look at your notes and look at some of the sections in the book, you should be able to find some more problems that deal with related rates. Okay, this next section of the test deals with some limits, and if you go back and you think about what did we do with limits, we had this section about L'Hopital's rule. Right, L'Hopital's rule said that if you got an intermediate form of 0 divided by 0 or infinity divided by infinity, L'Hopital's rule says take the derivative of the top and the derivative of the bottom, and then look at the limit as x goes to 0 of the result. So if we think about what happens here, as x goes to 0, this will be e to the 0 is 1 minus 1. This goes to 0. And as x goes to 0, the bottom goes to 0 also. So L'Hopital's rule says look at the limit as x approaches 0. Take the derivative of the numerator. The derivative of the numerator is going to give me e to the x. The derivative of the denominator is 1. And then look at what happens when x gets close to 0. So e to a number close to 0 is going to be close to 1. And the denominator is 1. So the answer here is 1. Okay. On this one, again, if you look at what happens as x gets close to 1, the natural log of 1 is 0. And then as x gets close to 1, this is going to be close to 1 minus 1. That's also 0. All right, so we end up with 0 divided by 0 again, so we can apply L'Hopital's rule. The derivative of natural log is 1 divided by x. The derivative of 2x minus 1 is 2x. And then we got to think about what's going to happen here. Well, as x goes to 0, the numerator is going to get really, really large, and the denominator is going to get close to 0. All right, maybe we should look at this another way and say the limit as x approaches 0, and then think about writing this as, instead of a fraction divided by something, let's write it as a product. So it would be 1 over x times the reciprocal of this would be 1 over 2x. So we get the limit as x approaches 0 of 1 over 2x squared. All right, and then as x gets close to 0, this is going to get close to 0. And then 1 divided by something close to 0 is just going to go to infinity. Okay, it's going to blow up. All right, third one here. As x gets close to 0, this is going to be close to 1. As x gets close to 0, this is going to be close to 0. And then minus 1. The numerator is going to get close to 0. The denominator is x squared. It's going to get close to 0 also. So again, L'Hopital's rule is going to apply here. So we take the derivative of the numerator. There we're going to get 2e to the 2x. Minus the derivative of 2x is minus 2. And the derivative of 1 is just 0. And then divided by the derivative there is going to be 2x. Alright, so now, as x gets close to 0, e to the 2x is going to get close to 1. This is going to be close to 2 minus 2. It's close to 0. And then as x gets close to 0, this gets close to 0. Alright, so L'Hopital's rule says that when that happens, just apply it again. Take the derivative of this. The derivative of that's going to give me 4e to the 2x. The derivative of negative 2 is just going to give me 0. And the derivative of 2x is 2. Now as x gets close to 0, this is going to get close to 0. E to a number close to 0 is going to be close to 1, so we're going to get 4 divided by 2, which is about 2. Okay, the next one is questions about parametric equations. Alright, when parametric equations is where we've got x and y are going to be points in the plane, but they're going to be dependent upon some other variable we call the parameter, in this case t. And so the first question here I think should be fairly easy for everybody. Find the position of the particle when t is equal to 1. Alright, well, when t is equal to 1, x is going to be equal to 1 squared minus 4 times 1. So the x-coordinate is going to be 1 minus 4 is negative 3. And the y-coordinate is going to be 1 squared minus 6 times 1 plus 8. It gives me 1 minus 6 is negative 5 plus 8 is 3. So this is going to be at the point negative 3, 3. Alright, then is the particle moving left or right when t is equal to 1? Alright, so to determine which way the particle is moving, we got to think about derivatives here. So the derivative with respect to x, or I should say, this expression here controls how the function or how the point moves horizontally in the x direction. This is going to determine how it moves vertically in the y direction. So really all I'm interested in is what is the derivative at 1 in terms of x. Alright, so the derivative of this function with respect to t is going to be 2t minus 4. And then, so x prime of 1 is going to be 2 times 1 minus 4 is negative 2. This tells me that x is changing at a rate of negative 2, which means it's moving to the left. Okay, and the reason is because this is negative, strictly negative. Okay, for what value of t is the tangent to the path horizontal? All right, so if you think about if the path goes something like this, and the path is horizontal, at that point, the y-coordinate stopped moving for an instant. All right, so what we need to do is find out when is the derivative of y equal to 0. All right, so going up here and finding the derivative, we're going to end up with 2t minus 6 is equal to 0, and that's going to happen whenever t is equal to 3. Okay, for what value of t is the tangent to the path horizontal? That's going to happen when t is equal to 3. And then again, the question is asking, is it moving to the left or to the right? So the movement to the left or to the right is going to be determined by the derivative of x. Okay, and I want to know what's happening when t is equal to 3. Alright, so we found the derivative up here was 2t minus 4. So the derivative here is going to be 2 times 3 minus 4. That gives me positive 2. And because this is greater than 0, that's going to be moving to the right. Okay, so if you want to look at some more problems on those are called parametric equations. Find the section in the book that corresponds to that, which is section 4.8 is parametric equations. Okay, the next one, this is when we first started talking about definite integrals. And we talked about, first of all, approximating distance from velocity. Alright, so find a left-hand sum, and by that we're just going to say we want to use the minimum velocity in each one of these intervals. So to find the distance traveled over this first 2 seconds, we're going to say assume that the object was moving at 0 feet per second and it moved for 0 feet per second for 2 seconds. Right, and then over this next interval, we're going to assume that the object was moving at 9 feet per second, and it did that for, again, for 2 seconds. And then for this one, we're going to assume that it was moving at 35 feet per second, and it did that again for 2 seconds. All right, so when we add these up, we're going to get 0 plus 18 plus 70. This is going to give me 88. Okay, and the units of this is going to be, well, this is feet per second and this is seconds. We're going to end up with 88 feet for the answer. Okay, and then the next question is this an over or an under approximation? And then we're supposed to explain why. Well, if you think about what we did, the left endpoint of each one of these intervals was always the smallest value. All right, so we're assuming that this object is going as slow as possible over each of these intervals, which would give me an under approximation. Okay, if you want another way of looking at that, you could look at, well, the velocity function is always increasing. Okay, and so if I think about what happens at 0 and 2 and 4 and 6, the values that we came up with, oops, this is actually going to go through the origin. Okay, and the values that we came up with were 0, and then the next one you can think of as the area of that rectangle and the area of that rectangle. And if you think about, the actual number is going to be the area that's underneath this curve, and we're missing, okay, 3 big triangular regions there. So again, this is going to be an under approximation. All right, and then part C says that the velocity of this car can be modeled by this function. All right, which is going to give me numbers that are pretty close to the values that are in the table. All right, and we saw later on that in order to find the distance traveled, all we really needed to do is set up an integral from, in this case it's going to be from 0 to 6, and our function is 9/4 t squared dt. All right, now we've learned how to find antiderivatives, so this is going to be t to the third, okay, divided by 3. We've also got this 9/4 out here, so let's just multiply those together, and then we're going to go from 0 to 6. All right, these will reduce. We're going to end up getting 3/4 of t to the third, so 6 to the third, minus 3/4 times 0 to the third. All right, and when we do that, we're going to end up getting 6 to the third is 216, so 3/4 times 216, and then this is just going to be 0. So if I take 216 and multiply by 3/4, we're going to end up getting 162. All right, so 162, and again, this would be feet. All right, so our approximation up here was 88 feet. Our actual number was 162 feet. We're off by quite a bit here. And I think the reason that we're off by quite a bit is we only took readings every 2 seconds, and we only went for 6 seconds. So there's a lot of error involved in this approximation of part A. Okay? All right, so you do need to know how to do stuff with a table. Find a left-hand sum. I could have just as well asked you to find a right-hand sum. And then is it an over or an under approximation? Okay? All right, so that's, I guess 5.1 was dealing with going from velocity to distance traveled. Okay, this next set of questions has to do with theorems about the fundamental, or about definite integrals, which I think was in section 5.4. All right, and I think that one way that we could look at this is these are all about the function f of x, and it might be a good idea if we just think about sketching a picture of what y equals f of x looks like. Okay, now this isn't necessarily the scale, but what I want to look at is we're going to go from 0 to 4. We're going to go from 1 to 4. And we're going to go from 0 to 6. Okay, so if we think about that as the values that were given. So from 0 to 4, the area underneath the curve from 0 to 4 is 20. All right, so maybe I'll write that as that's 20, okay, corresponding to the area up here. From 1 to 4 is 18, so maybe I want to mark this as 18 is from 1 to 4. and then from 0 to 6 is the whole thing, and that's 30. So that might make things a lot clearer as to what these values are going to be. So the integral from 0 to 1 is the area of this region. Well, if the area of this region is 20, the area of this region is 18, the integral from 0 to 1 has to be the difference between those two, is 2. All right, and then again, I think if we look at the picture, the integral from 6 to 4 is that area. All right, from 0 to 6 is 30. From 0 to 4 is 20. That's got to be 10. All right, then from 1 to 6, from 0 to 6 is 30. We found out from 0 to 1 was 2. This is going to be 28. Okay? Then we got this rule with, there's a constant in here. That constant then can be just pulled out of here. And we're going to get, this is the same thing as 2 times the integral from 0 to 4 of f of x dx. Okay, the integral from 0 to 4 we were given is 20. We're just going to multiply that by 2 and get 40. All right, then this is a question that I asked one like this on the quiz, and I think a lot of people missed it. And I want to go through this one and say, this one is one that you could split up. You can write this as the integral from 0 to 4 of f of x dx plus the integral from 0 to 4 of 2 dx. This number was given up above is 20. And then this one you can find by using the fundamental theorem of calculus, which says find an antiderivative of 2, which is 2x, and go from 0 to 4. Right, well, if you plug in 4 here, you're going to get 8. Plug in 0, you're going to get 0. So this is going to be 20 plus that's 8 is 28. Okay. A lot of people, I think, on the quiz, well, that wasn't the same problem, but most people, if you made the same mistake, would have came up with an answer of 22 here. You're just saying that this is 20 and then add 2 to it. It's not just 2, it's the integral from 0 to 4 of 2. Okay, and then the next one has to do with fundamental theorem of calculus. So this is, again, pay attention to the functions here. This is the function f of x. This one just says find the integral from 0 to 3. The integral from 0 to 3 is going to be the area of that region. All right, I'm looking at this as there is a rectangle here. It's 2 by 1. That area is 2. And then I see here that there is a triangle, and the area of that triangle is going to be 1/2 base times height. That's also 2. And so the integral from 0 to 3 is 2 plus 2 is 4. All right, then the next one is the integral from 2 to 4. So we're looking at going from here to here. All right, so I'm looking at this area and this area. All right, when the function is above the x-axis, the definite integral is area under the curve. When the function dips below the axis, it's going to be the negative of the area. So if we think about adding these two things together, they're going to cancel each other out, and we're going to get 0. Okay? And the next one is just 1 to 3. Okay, I think we answered that question already. That's just going to give me 2. All right, then this says if big F is the integral from 0 to x of little f, then big F has a local minimum at x equals what? All right, so again, I think it's important that you understand the relationship between these two functions. The relationship between these is that f prime of x is little f of x. So you can think about this as this is the derivative of big F. All right, so where is this going to take on a local minimum? Well, there's going to be a critical point here and a critical point here. And if you think about what happens at this point, the derivative is positive and then the derivative is negative. All right, if the derivative is positive and then negative, that tells me that the function reaches a local maximum there. Okay, at this point, the derivative is negative here and then positive over here, which tells me there's going to be a local minimum there at x equals 5. All right, so this is going to take on a local minimum when x is equal to 5. Okay, all right, again, I think that those are mostly problems from section 5.3 and 5.4, and maybe a little bit of 6.4. Okay, next one is just a bunch of functions that we're going to find by taking antiderivatives. So this was just going to be use the power rule, or yeah, the power rule. So we're going to end up with x squared divided by 2. That's going to get multiplied by 4, and then plus 3x. This will simplify into just 2x squared plus 3x, and then plus a constant. Okay, the next one, this might be easier if I write this as x to the minus 3. All right, so an antiderivative of x to the minus 3 is going to be x to the increase the power by 1. So if we increase negative 3, we're going to be at negative 2. And then we said divide by that new exponent. Okay, I can't use the power rule on 1 over x, but an antiderivative of 1 over x is natural log of the absolute value of x. So this is going to simplify to just negative 1/2 x to the negative 2 plus the natural log of the absolute value of x, and then plus a constant. Okay, then for this one, 6, I'm going to think of this as x to the 1/2 power plus, this is x to the negative 1/2 power, and then it looks like I can just use the power rule twice here. So an antiderivative of this is going to be 6 times, let's do the power first, that'll be x to the 3/2, and then we're going to divide by 3/2, which is the same thing as multiplying by 2/3, and then plus, if we increase this power by 1, we're going to have x to the positive 1/2, and then if you divide by 1/2, that's the same thing as multiplying by 2. Alright, so we're going to end up with the 6, and the 2/3 is going to reduce down to, what, 4, x to the 3/2 power plus 2x to the 1/2 power plus a constant. Alright, perfectly good to leave your answer like that. Okay, next one, an antiderivative of 2 is 2x. An antiderivative of negative cosine is positive sine plus a constant. Alright, the next ones look like problems that we did Monday night, which are u substitutions. Alright, and so for this one, if we say let's let u be 3x and du is 3 times dx, and then substitute in here, we're going to end up with e to the u, and then dx is going to be equal to 1/3 du, and so we end up with something that looks like that, 1/3 integral of e to the u du. So we get 1/3, an antiderivative of e to the u is e to the u. Okay, and then we're going to substitute back in, and we're going to get 1/3 e to the u was 3x, and then plus a constant. All right, so 1/3 e to the 3x plus c. Okay, this one might have been on the problems that we did last night too. Let's let u be x to the 3rd. du is 3x squared times dx. Substituting in, this is going to be cosine of u. Then I've also got this x squared times dx, and I've got x squared times dx over here. The only problem is I've got this 3 here, so let's just multiply both sides by 3, and we'll have 1/3, multiply both sides by 1/3, and then x squared dx is just du. An antiderivative of cosine is sine of u plus a constant, so we're going to get 1/3 sine of x cubed. Plus a constant. Okay, and then this one, I'm looking at this x squared and I see this x on the top, and I know the derivative of x squared is 2x, which makes me think that maybe we should let u be x squared plus 1. du is going to be 2x dx. Substitute back in, the denominator is u, and then I've got this x times dx left over, and I've got x times dx here, So if I take this equation, just multiply both sides by 1/2, we'll have that. And then x times dx is the same thing as just 1 times du. Alright, so this is going to give me 1/2 natural log absolute value of u plus a constant. So 1/2 natural log absolute value of x squared plus 1 plus a constant. All right, you might have noticed in the back of your book that sometimes they don't put the absolute values around this, and this is one of those where you could just as well leave these off because x squared plus 1 is never going to be negative. So putting the absolute value on that is just kind of redundant, that this number is going to be always positive anyway. Okay, if you wrote it with the absolute values on there, you would not be wrong. It's the same answer, but your book is going to give your answers sometimes with and sometimes without. Okay, so then the next set here is evaluate these definite integrals. So this is just applying the fundamental theorem of calculus. An antiderivative of 3x squared is x cubed. We're going to go from 0 to 2. So this is going to be 2 to the third minus 1 to the third. That gives me 8 minus 1. That's 7. Okay, here I think I want to use a u substitution. Let's let u be 2x minus 1. Du then is going to be 2 dx. So if I think about this integral, this is going to be an integral of the square root of u. We'll write that as u to the 1/2. Then dx is going to be equal to 1/2 du. So we're going to have 1/2. An antiderivative of this is going to be u to the 3/2. And then divide by 3/2 is the same thing as multiplying by 2/3. Okay? And so an antiderivative of this, these 2's are going to cancel. We're going to get 1/3 and then u to the 3/2, and u was 2x minus 1 to the 3/2. Okay, then we're going to plug in 1 and plug in 5. So we're going to get 1/3. If I put 5 in here, we're going to get 10 minus 1 is 9 to the 3/2. Minus 1/3. Plug 1 in here, we're going to get 2 minus 1 is 1 to the 3/2. Right, so 9 to the 3/2. If you raise up to the 1/2 power, that means take the square root. So this is going to be the square root of 9 is 3, and then cubed is 27. A third of 27 is 9. And then 1/3 times 1 to the 3/2 is just going to be 1/3. Alright, so we can think of this as 27/3 minus 1/3 is 26/3. 26/3 is that definite integral. Okay, these are the ones we talked about last night. This is taking the derivative basically of an antiderivative. And we said last night that if this was just x, then all we had to do really is say this is going to be the sine of, and just change this to an x. Okay, and then not plus a constant, but just that. Okay, and then this one, this is a little bit messier, so the derivative of this is going to be natural log of x squared, and then times the derivative of x squared, which is 2x. Alright, so the answer to this one is going to be 2x natural log, and again, here if I put absolute values on x squared or not, it doesn't make that much difference. And if you want to be consistent, just always put them on there. So 2x times the natural log of x squared, and that comes from the chain rule because this isn't just x on the top. Okay, so I think that that's a pretty good sampling of the kinds of questions you might expect to see on the test on Wednesday night. The other problems that you should go through are the ones like we went through Monday night, especially the ones that were like the take-home quiz. Yeah, I think that anything that's like that is also fair game on this test. If you have any questions, I will be in my office on Wednesday morning from 8:30 until about 11. And then I will also be at the exam probably around 5:30. And again, the exam is going to be in that same room that we were in for the other 2-hour exams over in Brace Lab. I think it's room 105. It's that same room that's right off the entrance to the right. Okay, so again, if you have any questions, let me know. You can also send me an email I'm also going to send you the solutions to this as an attachment to an email. Okay, good luck, and I'll see you on Wednesday.